We can actually look so far out that we can see almost back to 13.8 billion years ago, which is very close to the Big Bang. We now know how our world ends our affinity with sci-fi movies, and perhaps the Bible would point toward a big bad apocalypse. But what if we tell you that the end of the universe is no different than its inception? The James Webb Telescope has revealed that the universe has stopped expanding. Popular scientist Brian Cox made this prediction years ago, and in doing so, he gave us the most realistic starting point to imagine the end of the world. We can look at light that began its journey before there were galaxies. And that's the oldest light in the universe, which is, by the way, one of the pieces of evidence for people who don't believe in the Big Bang. The answer is simple, you can see it. We're heading toward Big Bang 2.0. Join us as we explore why the world has stopped expanding and James Webb's terrifying discovery. If we're certain about anything in our knowledge of the universe and its history, it's the fact that our very epoch of existence is centralized around this event called the Big Bang. Of course, there are alternative theories that recognize the beginning of the universe, such as eternal inflation or an oscillating universe, but we're not getting into the validity of these theories today. Mainly because the astronomical community has now readily accepted that our history in this universe starts with the Big Bang, and the ideas that succeed the Big Bang are also based on the same common point of the universe's birth. While the Big Bang is a common word in the theoretical knowledge of astronomy and space, we're hardly aware of the whys and the hows of the phenomenon unless you're a nerd who has spent hours watching some excellent visualization of the Big Bang. To be fair, the phenomenon was more than an explosion, so to speak. Simply put, the Big Bang finds its origin in a single point, a point that was infinitely hot and dense, which inflated to extreme lengths. All of this happened when the universe was incredibly young. Believe it or not, at the time of the Big Bang, the universe was only 10 to the power of minus 34 seconds old, that is, a 100th of a billionth of a trillionth of a trillionth of a second in age. This is when the universe experienced an incredible burst of expansion, aka the infamous explosion or inflation. During this process, space expanded faster than the speed of light, so yeah, you wouldn't have even blinked when the universe grew 90 times in size almost instantaneously, from subatomic size to golf ball size. 1 second after the inflation, the universe began to cool, and that led to the formation of matter as we know it today. So yeah, as far as the timeline goes, within a second, our universe was full of every particle we've learned about in our chemistry class. Willingly or otherwise, protons, neutrons, electrons, anti-electrons, photons, and neutrinos are the legacy of the Big Bang. Magical, right? Well, figuratively, it looks like it, but our understanding of the universe's inception is highly theoretical. We've come a long way since the first moon landing, and since then, our technological advancement has grown exponentially. Back when scientists were studying the Big Bang based only on mathematical formulas and scientific models, they wouldn't have imagined that we'd be exploring the possibility of life on Mars. There have been some big breakthroughs in our pursuits to study the universe and explore space, yet even then, our existing technology is pretty limited. You see, we can't recreate the Big Bang or peer back at the event itself. Our biggest piece of evidence comes from the cosmic microwave background that has allowed scientists to observe the echo of the Big Bang. While this mechanism is groundbreaking in the study of the universe, it's also theoretically limited. The biggest barrier in this particular methodology is the fact that we can't see the gravitational waves or the residual radiation that came from the expansion itself. So while our entire knowledge rests on theoretical tenets, scientific theories have a large room to be disapproved of as well. Yep, we're pretty sure about the Big Bang as a concept and how it was monumental in creating our universe, but there are some chunks of its aftermath that we've gotten wrong. And as shocking as it is, theories about our universe are largely based on data that is prone to human errors all the time. At the same time, some of our data is also highly conclusive about the Big Bang. Let's just say that, at this point in time, it's not easy to disprove the theory altogether. Is our universe still expanding? In the last decade or so, our only saving grace to study the Big Bang was the Hubble Space Telescope. And now, of course, all bets are on the excellent precision of the James Webb Space Telescope. Before we got to use these powerful technological instruments, one of the biggest points of contention in astronomical study was the expansion of the universe. If you read some science textbooks from the early 90s or so, you'd read about how the universe is widening. In other words, the universe is expanding, and that's one little scientific fact that we've held on to. But the real snafu here is that perhaps we don't understand what the expansion of the universe entails, and more importantly, we've got to ask ourselves if the universe is actually expanding. Because spoiler alert, James Webb Space Telescope is telling us otherwise. Lo and behold, the universe has stopped expanding. While the world is still intact, you might want to improve your internet experience safe and secure, because we certainly have. This is why we're happy to reveal our very own secret to secure browsing and accessing deep blocked content to make some hefty informative videos. Today's video is sponsored by the champion of safe and accessible internet, Atlas VPN. With more than 6 million users worldwide, Atlas is changing the game for everyone. Alright, this service won't be available in space, but Atlas would make your internet experience super secure and quick. Can't watch shows that are locked in your region? Connect Atlas, and within a microsecond, voila, you're in. You don't have to be an expert in tech or computers to work this service. It works like a charm for anyone and everyone. Why choose Atlas? Atlas kills malware attacks, keeps your searches secure, unlocks content from all over the world, and offers the best deals in the market. Protect your privacy and get many benefits of Atlas VPN for a ridiculously low price now. Before jumping into the implications of this groundbreaking shift from our universe's trajectory, let's talk about our understanding of this perplexing phenomenon in the first place. The discovery itself is profoundly frightening, and while it isn't overly unexpected, it sheds light on our universe's susceptibility to a collapse. In cases where the universe has an ample amount of energy density, its expansion would eventually stop entirely. By the looks of it, our universe is going backward. So, let's unpack this. Back in the 1990s, NASA and its credible scientists had some very conclusive ideas about the expansion of the universe centered around gravity as the most fundamental unit of their scientific understanding. While this still holds true, new ideas have emerged regarding the speed at which our universe expands. Scientists predicted a possible recollapse of the universe, which would cease the expansion we see today. However, an equally terrifying possibility was proposed: too little energy density would mean that the universe would never stop expanding. Back then, with limited technology, finding tangible or observational data was difficult. What scientists were certain about was that as our universe aged, gravity would decrease the rate of expansion over time. Intuitively, it made sense since gravitational pull brings galaxies together. As the universe expanded, gravitational force would resist widening the distance between heavenly objects, keeping matter intact. The theory was also extended to predict the rate of the universe's expansion. Since gravity acts as the binding glue for all matter and has existed since the universe's inception, the expansion rate was expected to slow down. This theory made complete sense until 1998, when the invention of the Hubble Space Telescope had changed everything we knew about the universe. Hubble was effectively used to study distant supernovas that explained the fluidity of space. The findings were completely opposite to what scientists knew, leaving them dumbfounded. For the first time, seeing was believing in astronomical studies. It turned out that gravity wasn't slowing the expansion of the universe at all. Rather, the universe was expanding at an accelerating rate, faster than ever before. This unexpected theory was hard to explain. Gravity should have been fighting to decelerate the universe's expansion, but by all accounts it was rendered powerless. To this day, we don't know why the universe was expanding at such an astronomical pace, unless an anti-gravitational force was overpowering gravity. Until the recent discovery of the James Webb Space Telescope, scientists largely believed our universe to be a battlefield between gravity and dark energy. After Hubble's discovery, the scientific world was in crisis as agencies like NASA sought quick explanations for the unprecedented cosmic acceleration. One theory was that perhaps Einstein's theory of gravity was inaccurate. As per the theory, gravity, viewed as a distortion of time and space caused by mass and energy, should have prevented accelerated expansion. Another explanation involves some energy fluid hastening the expansion, but these theories came and went. Today, the only answer to Hubble's astounding discovery is summed up in 2 words: dark energy. Yet we know almost nothing about this force except that it makes up the majority of our universe.